Good evening, everyone. Tonight's topic is just an introduction to FDM 3D printing. And if you don't know what FDM is, you will by the end of the presentation. And my subheading here is what I wished I knew before I bought my first and second 3D printer. So we're going to kick things off right now. For those in the hall, I get to see it, a live demonstration. So while I'm doing this, we're going to commence an actual 3D print that will be running, and it will point the camera at a couple of times during the presentation tonight. And at the end, and if I've timed everything right, it will actually be finished printing about the time I finish this bit of a chat. I did try it, so it's somewhere close. Okay, so we're just going to move on, have a quick look at the things we're covering. A few little bits and pieces there. These slides are a prompt for me. I'm not reading them. So a lot of words, a few pictures. So I want to mention just one thing about home and hobbyist 3D printing. Does anyone know why 2008 or the end of 2008 was significant in 3D printing? No, not quite right, Mark. Mark said make a bot, but he's almost right. November 2008 was the very first commercially available 3D printer that was considered hobbyist, sub 10,000 USD. So this is a very, very new technology if we think about it in terms of that, in terms of what you can buy a printer now, that even the crappiest thing you can buy now is orders of magnitude better than what 10 grand bought you in 2008. So that's just a little thing to think about at the moment. So I'm not going to read, as I said, not read the screen. Really looking at generally what a hobbyist printer, an entry-level printer, starting around $300 mark. You don't get much of a printer for that. Up to around 5K, but you can get a very, very capable printer and set up for about 2,000 to 2,500 AUD. So yeah, somewhere to get started with. I'm not going to cover every brand by any stretch of the imagination. I'll cover two or three that everyone's possibly heard of or knows about if they've started looking for 3D printers. When I started looking and digging, there's I think I stopped counting at about 150 different brands or manufacturers of printers in this market space. So. And like I said, it's a full-on intro. I'm not going to teach you how to do 3D CAD modeling. That's a whole subject in and of itself. And you don't need to know that before you buy your first or possibly even second 3D printer. Yeah, learn the basics, as I said there. So there's just a handful of the things I'm going to try and cover briefly. You won't get everything you need to know on them, but you'll get something to get started with. So, and if you look at the order I've put things in, it's for a reason. Deciding on your first printer is about the 7th or 8th thing on your list. You need to know a lot of other stuff before you even think about making that purchase. I can see a nods for a couple of people in the room that I know have been down this path. So, two types of generally used home 3D printers. So you've got MSLA, or commonly referred to as a resin printer. So it's a big pool of resin. They shine UV light to cure it. Yeah. And of course, FDM, so fused deposition modeling, which is the sort of printer we've got sitting here showing you now. So basically, FDM is just a very, very accurate hot glue gun. Yeah, so resin, there's pluses and minuses. You can get incredible accuracy and tolerances within your print or curing of the resin. Damn messy and long process, and who wants to be dealing with resins and wash baths and cure chambers, and it goes on. Whereas FDM, I said at the end of the night, we're going to show you something we've printed right here, right now, that's a usable little thingo. So relatively simple, relatively easy. And I guess the beauty of it is for prototyping stuff, it can be super, super fast compared to older methods of prototyping a product, which would be model it, build it in plaster, make a female mold, cast it in metal, and then work out you're out by 0.5 mil somewhere and start all over again, which takes days. So very, very thing. So first off, we're going to have a look at some of the places where we can find stuff to print. Go to the website. It's a lot of popularity in the years. There's websites you can find. You can think of something. Someone else has probably already done it. No need to make your notes. I'll send this out at the end of the presentation to the mailing list. So all good there. There's a handful there. All the big printer brands will have their preferred one or one you log into. Look, but yeah, like I said, some of those websites, I reckon I could probably go to Thingiverse and type a couple of random words, and I could probably find you 20,000 different objects to print. No problems at all. There we go. So what we're going to do is look at some of the filament types. So there's you just think it's a roll of plastic, but there's lots of different properties on all these filaments. I am going to read a bit from here because I put some details to remind myself specifically. Most common, everyone says PLA as a general purpose filament. Say it's biodegradable. That's debatable. It takes 70 years to break down and compost. It's not really biodegradable. But it is actually, it's a long strand polymer made from starch. So plant material, but it's modified that heavily. It's, unless you've got an industrial composter, it's not biodegradable. I've got a whole lot of numbers there next to the filament type, the PLA, for example. I've got like 50, 210, 60. So those numbers there, the first two is, which we'll talk a little bit about later on, and hopefully we'll get some questions. We can go through those. So there's a few properties of our printer. So to successfully print PLA, we'll want a heated bed of approximately 50 degrees C. And the next one is the extrusion temperature, the temperature we need to melt that plastic to actually push it through the nozzle and make our widget, whatever it might be. And then the last number, it's more of an interesting one. It's one of the probably the basic mechanical properties of the material, and that is where that type of material, what temperature that one will start to deform and change its shape at. So PLA is good up to 60 degrees C. So don't print something nice and leave it on the dashboard of your car, or it won't be that object in an hour's time in summer. And like I said, very, very good general purpose material, cheapest material to get hold of, hundreds of places to get it. 20 bucks a kilo. So what, 20 to 45, depending on some of the other properties we'll get to in a minute on it. And like I said, these are the three easy filaments. Every one of these you can print on that printer with no fuss at all. We could do all them. So the next one is PETG, basically what your all your plastic drink bottles are made of. It's similar properties, similar capabilities or difficulties to print as the PLA, a little bit hotter, a little bit more challenging. It'll survive a little bit higher of a temperature, but the beauty about PETG is great for, it's the cheapest, mostly UV stable material we can use to print stuff with. So that's all pretty useful on that one there. Slightly more expensive, 30 to 50 a kilo. And we'll get to how much do you think you might be able to print with a kilo of filament. It's quite a lot. And the other one, which is TPU, is a flexible material. So once again, you see some temperatures there. 30 on the bed, 230. And I've got an NA for the temperature it deforms at. Because it's flexible, it can deform at room temperature and be perfectly usable what it's designed for. So just on that one, the TPU one, I'm going to pass around a little object for everyone in the room here. Just hold up the camera for a sec. Put the camera on it. This is something I printed. I bought myself a new phone, and before my very expensive quad lock case come along, I was not going to drop a very expensive phone on the floor. So I spent $1.71 and made myself a phone case. So we'll just pass that one around. Everyone can sort of see that's the stuff you can print at home right now. And that print looks like it's just gone through and just starting to do the first layer. So like I said, yeah, these will be majority of the times, these three materials are your go-to materials. They're quite cheap, quite easily available, and you'll do most of your general stuff with those. And now come a handful of the 3 or 4 of the more fun materials. or dare I say, challenging materials. So from the top down on in every case, I'm sort of listing them in order of user friendliness because they can be a little bit more tricky as you print them. Like I said, I didn't sort of mention PLA is very easy. PETG is similar, but a little bit more difficult. You get some stringing when you print it. Got to be a bit more careful about some of the parameters. And these ones, I call these ones the start of the engineering exotic materials. So, and it'll become a bit clearer when I start describing a couple of different main parameters of the basic printers we're looking at. So ABS. ABS was probably, I'd say, it used to be the mainstay material as of maybe more like 10 to 5 years ago. People have moved away from it because when you print it, it's got, like I said, moderate print difficulties, good mechanical, but hell, I wouldn't want to have it be in the same room while it's printing toxic fumes. So run it out in your shed or run it through a HEPA filter. And as we can sort of see, the temperatures and the mechanical properties there are much better. So it's survival to about 87, 88 degrees, so about 30 degrees hotter than your basic materials before it'll start to deform. And now ASA, it's a modified ABS, and don't ask me to tell you the actual chemical names for these bloody filaments. They are too difficult for me to pronounce. You're getting the abbreviations. Google is a friend. So ASA is what we call, it's once again, it's a moderate print difficulty, but it's a much improved ABS. In fact, that it's, yes, it'll survive 100°C, so not quite boiling. And it has actually got better UV properties than PETG. Still got toxic fumes, not quite as toxic as ABS. Then the next one, PA, or that's why I said it's nylon there. I don't know the name. Once again, you're looking at you're dealing with much hotter temperatures with these engineerings and exotics, but they've all got some really good mechanical properties. I have not tried printing nylon. We've been doing this for about 6 months. Notoriously difficult to print, but if you get everything right, it's a great material, and everyone's sort of probably aware of the properties of that. I think anything that's got in your home that's got a small mechanical gear in it, that's nylon. And and once again, prices are there for the PC polycarbonate, even harder to print than nylon, but you want to print yourself a helmet, go ahead. If you've got the patience to learn how to dial in and deal with the material. So it's all these, once again, they're all got all the mechanical properties are there. So so before we even think what printer we're going to do, understanding the properties of the materials that we can print can really influence what we can print and make things a lot easier on our choices going forward. And for those in the room, I've got got one more here. We'll start handing around. We've got a sample of 6 different types of filaments there. You can sort of, just a small length of the type of material that they're made of. And looking at them, you literally, the only one that you can tell what the material is, yes. No, just open them out, open the bag up, just hand them around. Just feel them, look at them. There's only a couple there that I say you can notice the difference of. The black one, please don't rub your hands on it. It's got small 0.2 to 0.3 millimeter pieces of stranded carbon fibre. So don't rub your fingers backwards and forwards on the black one. One of the other ones, the PLA, is the only one that really feels any different. Physically looking at them, it's very hard to tell the difference of what each material is. So, and there's lots of modifiers from the basic polymers for different properties, like you can change the appearance, and common with PLA is the addition of silk, actual silk, change it to a more matte finish and colour variations through it a little bit. So that's something decorative you might want. Is it a silk one, that one? Yeah, pass that one around there. Hold that one up there. So this just like a little decorative vase here. It's fairly fragile due to the way it was printed, but that's a tricolour silk material there for those on there. So, and it's very, very different looking than a standard, like more shiny one. So we'll pass it around to everyone and have a look at that one as well. That was silk, yeah. And same with that other box there, which we'll talk about more about that later. So just a couple of items you can actually put your hands on, have a look at, to go around there. So that's one of the modifiers. So with all these modifiers, they will change the basic chemical properties of the materials, and in some cases, they'll make the material weaker. And in some cases, they'll make it orders of magnitude stronger and more mechanically sound. So silk, as we said, it's not as strong. So it weakens the base material by about 20%. But they look pretty cool when you sort of see them do some things. And once again, I've got some notes here about the standard nozzle, which I haven't covered yet. It's the little hot bit where the material comes out. On the bottom is the nozzle. And the standard nozzle. So that can be printed on any printer as well. All these other, I'll call them exotics, they need a different nozzle because they are abrasive or very hard, and they'll rip your filament to pieces. So glow in the dark is a pretty cool one. Additive to any of the basic filament types. So your PLAs, your PETGs, change colour when you turn the lights off after they charge off you. Non-radioactive. Where's the fun in that? CF carbon fibre is as we said, yeah, sort of think of any mechanical things they make out of carbon fibre, lighter, stronger, etc. Same mechanical properties here. And as I mentioned, very small strands of it there. Impact and deformation resistance improves by about 20 to 30% on your base material mechanical properties. So it makes it a much tougher thing. All these things come at a price. Start adding exotics, the price starts going up in your base material. So rather than paying like $40 for your ASA, you might be paying 50 or 60 bucks for your carbon fibre additive. So I think some of us have interest in having things that are like outside. So you might think, where could I use this? ASA, carbon, something I need strong. But I probably wouldn't want to use carbon fibre as a support on the end of my dipole because it's damn conductive. Go to glass fibre, which is, yeah, once again, it's even worse than carbon in terms of the particles and things there. You've got to be a bit careful handling. You don't go rubbing that on yourself. And once again, it adds, the strength that glass adds is not quite as much as carbon, but it does have that wonderful insulating property. So your insulating characteristics of your base material is improved by having a glass component. Okay, the slicer. So all 3D stuff you do is comes out of a CAD package or otherwise as a certain file format. That file format is absolutely useless for that piece of mechanical device there to understand and print. So the slicer, as I said, it's a workhorse software. It basically takes your object and builds it in layers, depending on the resolution you set that. Most typically, it'll be from 0.06 of a millimetre, 0.06 millimetre increments, typically being 0.2 of a millimetre steps. So it'll slice it in multiple layers. Your slicer is the software that basically turns that solid object into a set of instructions to move the X, Y, and Z and tell it how much of that molten plastic to squirt out and when to squirt out. So getting around it, you need to learn a slicer, and most people getting a 3D printer, every manufacturer will have a preferred slicer. Your first week you'll use it, then you'll turn it off and won't use it. You'll actually go and which one's the best one? Yeah, you'll end up with Orca, or you'll end up with one of the very, very expensive paid for ones, which unless you're doing it for a job, you wouldn't bother with. So yeah, start with whatever the manufacturer of your printer you get or using says. Till you've done your first print or second or third, then you'll use one because it's just much easier to manage and control when you edit. So bit of a learning curve. It's going to take you a while to learn it, but it's the price we pay for being, like I said, we're early adopters. We're only, like I said, what are we? Not even 20 years into this game called home 3D printing. Here we go. So now we've covered a little bit about the materials and mechanical properties, some of their details about how we can print them, and we've mentioned nozzles, etc. Now we're going to look at the two different styles of FDM printers. Oh, I might get my arm off there, is it? Is it? Oh, I can't see over there. So is that all right? Don't know. Okay. So there's two mechanically different arrangements for FDM printers. So, well, it's commonly called a bed slinger. So it's a Core XZ printer versus a Core XY, and the other one's a Core XY printer. So XZ means that if we look at this one, the bed stays stable in the Z bed slinger. The bed is fixed in the Z plane or the vertical, and the print head moves up, but the bed moves forwards and backwards. So that's in the Y axis, and the head moves in the X and Z plane. It's built to a price. This is the cheapest way they can manufacture or mass produce these style of printers. So it's always going to be slightly cheaper to go for this style of printer. And there are, yeah, if we look at the physical footprint your printer takes, you don't be mindful of just the base of it, because that, as we can see on there, the build plate, the bit that's moving back and forwards, the objects are being built on, extends beyond the basic footprint. Whereas a Core XY, the difference is the print head moves in the X and the Y, and the bed is on a platform that slowly moves itself away from it as you're doing a build. Therefore, it's in a fixed physical space. Couple of different things. So they're slightly more complex to actually build. Slightly dearer. They have a starting price of around about $1,000. So, yeah, slightly small number of models available, and they lend themselves slightly better. Well, they are much better to being able to enclose your print space, being fully enclosed. And that becomes important when you look at the difficulty level of printing some materials. You do need an enclosure, very, very carefully controlling the print environment. Most people, bed slingers for basic stuff, there's absolutely nothing wrong. Everyone advertises that they're super fast, but they're all good. But if we see, you're seeing on the Zoom there and the screen there, physically moving around, as we get taller and taller and taller, the chances of more inaccuracies and errors grow the higher we build with a bed slinger, because the object itself is moving in motion the whole time it's printing. Whereas the other way, the object is stable because it's just moving in the Z axis, just moving away from the deposition of the filament. And of course, being the bigger footprint, if you wanted to enclose it into a different, have an actual enclosure, you need a physically larger enclosure to cater for, you're moving cables, you're moving bed to be able to do that. We just got a couple of pictures. Sick of words, sick of me talking. Yeah, I made some pictures, especially for you, Grant. You wanted pictures. So here's an example of, I'd say, probably 3 different types of basic, I'll still call them basic FDM bed slingers. So everyone pictured there is sub $1,000. So just like a Prusa. That particular model, no, it's not sub 1,000 because it's got the dual head with multi colours on it. Then you've got in there a Creality Ender 3, pretty much what you see sitting on the table. And also there you've got a Bamboo A1 Mini with an AMS, which is an automatic colour changer. And believe it or not, yeah, it's sub $1,000 and manages multiple filaments and filament changing. So yeah, the Prusa one is just over $1,000 there with the dual head colour changer on it. It's just a little bit with a single one. So they're just some 3 examples of 3 fairly common print names you're going to come across when you start diving in looking, because if everyone thinks back to Scott's presentation, he was talking about his Prusa. And even when you look back there, even as little as, when was that, 3 years ago, or 3.5 years ago, I think, he did his presentation. You go and look at the price of getting into 3D printing then. Prusa was literally the only game in town. And honestly, if you didn't have 3.5K in your pocket, you were not going to start. So even 3 years, we've seen a price drop by about 85%. So it's really making it very affordable if you want to start learning, maybe not necessarily printing, but the technologies and how it all works behind it. And some of the other ones there, like I said, multiple colours and material management, which is really quite cool. I'll go to two more. These are more of the Core XY style printers. Bamboo X1 or P1 with an AMS, so automatic material system. So everything listed there is 1,500 to 2.5K. So Bamboo make a couple of different models, about $1,200 and $2,300, or if you want to pay their exorbitant price for their engineering level ones, it's $4.5 grand. I don't know the Prusa model number. That's once again, they've got I think it's a Mark IV. They've got a Mark IV and one of the Mark IIIs. They got a Core XY model. They're fairly new to their lineup in terms of being around. And finally, for those that want their hobby to be building and playing with 3D printers, forget everything else, what everyone says, buy a Voron. You'll probably spend 60 to 150 hours to assemble that one. It'll cost you $2,000 for a box of parts. But by all accounts, everyone that builds one and has one swears by them until you take the other rubbish and throw it in the bin. Right up to the 10K plus printers. So everyone who does, but I want a 3D print stuff. I don't want to be building 3D printers. So there's something in this for everyone. So we've had a bit of a look about the materials, and we talked a little bit about some of the properties and some of the bits and pieces there. Handful of the things we're going to consider that sort of start tying together the things we've been looking at. So, and some of the things that you sort of see as important, or otherwise, some people, the first thing they're going to say, oh, it's how big does it print? You know, at the end of the day, almost inconsequential. If it'll do 200 by 200 by 200 mil, it's going to print 95% of the stuff you want to do. So the picture I had up there of the A1 Mini is 185. So 185 cube, and lots of people use them to manufacture and do stuff with. They're just pretty good. So some of the things I said, if we look at the materials we're looking at, the first page, like the basics, every single one of those materials printed on any printer you can buy. Start going to the exotics where you need to control the environment. You really need an enclosure. When it comes to a bed slinger, you've got to be a little bit more thoughtful about, can I get an enclosure? Can I make one? Yeah, sure. 3D print all the parts, get some Coro board, bolt it all together. It'll be physically large, but it doesn't matter. It does sort of mean with those printers you can expand your scope. More so is, am I printing any of these materials that exist? Let off some nice toxic fumes while you're printing. Where am I going to print? Am I going to put it out in the shed and run backwards and forwards the shed, or God, of course, everyone does it. Put a camera on the thing so you can look at it on the app. So there's that option too. So your environment, and then again, or a fully enclosed printer with a nice HEPA filter in there that you run a fan on it for 30 minutes to get rid of those toxins before you open the cabinet up after doing a print. So the print nozzles, I did mention a little bit about those there and the hardness of the material. Most common print nozzle is made of brass, and the most common size is 0.4 of a millimetre. And really the 0.4 size is so you can get down to those super fine 0.06 of a millimetre layer size with the amount it pushes through. There are smaller ones, 0.2 mil nozzles. Problematic printing some materials. There are larger ones where the final finish of that is not as critical, or quick prototyping, 0.6, 0.8, and if you really want to go to 1.2, but that's using it. And brass is a relatively soft material, so we can print the basic materials, start adding things that are hard. Anecdotally, 1 kilo of carbon fibre filament through a brass nozzle, brass 0.4 millimetre nozzle, and you've probably got a very nice 0.9 millimetre nozzle by the end of a kilo. So very harsh on it. So think about the nozzle. They're all interchangeable, replaceable. The next step up there, the next level or better printers are all, they'll step up to like a hardened steel. There's other variations like stainless encased brass, but they're a food safe material. And of course, at the top of the heap of all things is a ruby, and it's the actual gemstone drilled out, put in the tip, 0.4 millimetre hole in it. Because if you look at the hardness scale of ruby, it's the most affordable filament, and you probably, just some notes I was reading with them, you might see a 0.005 millimetre variation like that with 10,000 kilos of one of the hardened materials. So they're very robust and capable material, but just that tiny little bit of brass with a ruby embedded in it, 60 to 150 bucks depending on the quality. 60 bucks made in China, and the ruby will survive, but the hot end will fall apart. 150 bucks it'll last. So that's the nozzles. So, and that, once again, everything's tying back to what do I want to print? What are the materials I've got? Okay, we also looked at the materials, the hot end temperature. The hot end it's enclosed. If we look at the picture there, it's enclosed inside the black case there. We're feeding a bit of filament there at room temperature into there to heat it up, just to push it through a 0.4 millimetre nozzle, running at our filament temperature of somewhere between 195 and 340 degrees on some of the materials. And some of the cheaper lower end printers, they max out at 260 degrees C. So what do I want to print? If I want to print one of those materials that I need 260 to 300 C, I've just done myself out, and I need to think about upgrading a hot end, which you can get. Just about everyone has a third party and aftermarket hot end. You start modifying your printer, and why didn't I buy a dearer one to start with so I didn't have to play with? All things to consider. So 260, most of I'd say once you get away from the sub $500 printers or sub $1,000 printers, most are either 300 or 320 hot end as standard. And with 300, I haven't encountered anything I'd struggle with or try to. If I was going to go to nylon, I'd make sure I had something that was at least 20 degrees hotter than the hottest you want, just so you've got a little bit of capacity to fine tune as we go. And your bed temperature. So we haven't really talked about why we have the bed that we build on is of a certain temperature. And it's all about, so the material we're printing stays stuck while we're doing the print. And also, so by having it at a certain temperature, the adhesion while we're doing the print is good and stable. And we don't get rapid cooling and deformation and things bending on corners. Not sure, is that one with that green case? Is that one of the ones that we had? Sorry, the yellow one. Is that one of the ones where if you look carefully on that, one of the corners on one of the sides, you can sort of see it's not dead flat, and it started lifting as it was cooling. We just didn't have the temperature quite right. If you know where to look, you can see it's just not square and flat. And as we sort of saw, bed temperatures, adhesion, it's very rare to get anything over 100, but up to 120 is good. And most beds, because once again, it's a fairly new thing. Even as little as 3 or 4 years ago, most did not have a heated bed, and you had to be very, very careful about your environment of printing. There's so many other things that I haven't even covered in there. I'll mention it. Auto bed leveling. So the bed automatically levels, so you get everything perfectly on that plane. Haven't written it down because as of now, there is not even a basic low-end printer. If you went and bought new today, I don't think you can buy new a printer that doesn't have auto bed leveling. There might be a couple, but I put that in the almost inconsequential now. We've moved beyond those sort of things. Nearly everything. That there is a $400 printer sitting there. It's got auto bed leveling. So that's why I sort of glossed past it. You've got to go really, really low. And once you go that low, you're starting looking at lower temperatures and you're limited to literally printing 3 materials anyway. I've literally listed just up 3 brands there because they're sort of a couple of people have heard it. I'm going to talk a little bit about them. Anyone that's even heard of 3D printers heard of a Prusa. If they haven't, I'd say they haven't even had their eyes open at all, because it's Prusa is basically their business model was everything's open source. They'll sell you the product, but it's all out there. So, and they were once again one of the big drivers to bring that affordable price point as we started seeing them coming, certainly sub 5K. They were just the right place at the right time, and their business model worked. So that's all good. And yeah, there'll be a little bit of work to set up and play with, and maybe a bit of, I think they've got options these days on minor to major assembly, how much you want to do, whether it's a box of bits or a half-hour assembly of putting a few components together and setting up. So there's still a good option, and they've got quite a decent range of printers from small volume bed slingers to Core XY and quite large volumes you can print. I mentioned Creality because it's retail available, and everyone who's ever walked into a J car has seen them in the last year printing crap out. And quite often it'll be the first printer you'll go and get. So, okay, so you just found out that was my first printer. And by my introductory comment, you've probably realised it's not my only printer. So, yeah, so that's like a relatively low-end printer there. And I said we've talked about the shortcomings of moving objects and things. Printing out stuff, it does an okay job. You're going to have a few issues, not perfect. Start printing tall stuff and it turns bad really, really fast. Failed prints all over. And the other one I'm going to mention is Bamboo. They're a fairly newcomer to the market. And I'll talk about them for a couple of reasons, the good, the bad, and the ugly. Let's call them the iPhone of the 3D printers. Now look at that, while we've been talking here, these little objects of finished printing, and I'll talk more about them in a minute. It's a couple of doorknobs, by the way, and the significance of that is when I show you a little bit more in a few minutes. So the Bamboo, like I said, is the iPhone of 3D printers. It is the only ecosystem of any 3D printer where it's fully closed and non-hackable. So the good, they are an excellent printer if you just want to buy a printer and learn nothing, load something up and print it. I reckon in 600 to 700 prints on it, like 150, 200 hours. There's been 3, maybe 4 failed prints that have not been my fault. Whereas a much cheaper printer, the first few months were a journey on learning about 3D printing. But it's also a very valuable sort of thing to learn about the functions of how it works, how the software works, how to get it exactly right, and how to make the configuration in your slicer to your profile to suit every filament. Understanding how it works, it's a great learning tool, and for that reason alone, I wouldn't dismiss it as, if it's in your budget, it's a great way to learn about it. And yeah, you learn so much about it, then you're thankful when you move on to a very, very capable machine that costs 4.5 times as much, because I just wanted stuff to be printed. So yeah, so some people say that's the bad thing, because it is a closed ecosystem. You can't get there, hack the software, can't do anything. But so far they've been proven to be very, very good at addressing community concerns, software updates, the whole lot. So they've been, and of course you're going to get your fanboys, of course, because it's a closed system, just like Android versus iPhone, exactly the same thing. But I considered both before buying the first, and I literally said, no way, I'm not buying something that's fully closed source. I want something I can play with and do. yeah, the choice was good because I learned a lot about 3D printing before I found a tool. So that's just like a little thing there. So handful of must-have accessories. Okay, I'm putting their camera because everyone wants to see their object print out while they're sitting when the printer's in the other room, or do that time-lapse photo of that 17-hour print that takes 1 minute to show on your screen as it builds layers up, or get to 15 and a half hours and realise it's failed and go, oh crap, here I go again. Michael's just laughing at me at the moment. Yes, spaghetti monsters. Everyone's seen them. So, and this is one thing here where we are relatively lucky in South Australia. All these filaments absorb moisture, which is a negative impact. You're pushing it through the nozzle. If that's 40% water, you're pushing it through at 260 degrees. What happens? It's steam. You haven't got filament. You've got air gaps and bubbles and all sorts of garbage going on. Ideally, only had one bad filament that's caused problems. And I try and keep them sub 40% humidity. So as long as you're not sitting inside in your swampy, South Australia's almost perfect. So storing of your materials, desiccant. So you will start collecting desiccant bags out of everything you find. Or kitty litter because it's damn cheaper. Yeah, and big Ziploc bags, you can keep your filament in. Filament will last for a long time if you can keep it dry and treat it right. Didn't pick one up. So they're in large Ziploc bags to store it. So, and you are going to, I'll get to questions at the end. Thank you. Yeah, keep them dry. And you need a handful of basic tools. No matter what, you're going to have to be modifying and playing with these damn things. Whether you like it or not, you'll be taking apart things and doing a bit there. And doing it. So most of them come with the basic things. So regardless, get yourself go and spend the money. Oh, hardly worth it. Everyone's seen a desiccant bag. It's a tiny little one. I was unpacking some stuff at work and I picked up 5 kilos of desiccant, saved me $90. So there's some very basic tools you will need to do. Things will break. You will need to change them out. So handful of accessories there. The other one I didn't mention there is a scraper. So sometimes when your objects are on the hotbed, you'll need a scraper to get them off, and you don't want to use a metal scraper, or you can destroy your hotbed. So while the camera's on there, you just want to pop that one off and just watch it. They should just fall off. We specifically left these objects sitting here so they're nice and cool, so they come off in front of the camera. So they come off relatively easy off the hotbed. You pass them around there now. Anyway, obviously those in the room can't get to feel and touch something that was a coil of plastic a few minutes ago. So, well, when we started. Okay, so what I've hoped I've gone through here is a little bit about, you know, what the materials are, a little bit of the materials, where you can find stuff to print, some of the properties of the printer you might want to consider, so we could tie it all together so you can decide what is the right printer for me if I want to get into this now, or even just some basic background of thinking as things progress. I think a lot more people will be doing 3D printing, fast prototyping, or making objects within the next 3 to 5 years for sure. So it's always good to have it. And hopefully there's sort of giving you enough information on a little bit of the background of, I would have loved to have understood, like, what temperature thing do I need? Yeah, bed slinger versus Core XY. And hint, Core XY can print roughly 3.5 times faster than a bed slinger. That advertises as whatever speed is, 150 millimeters a second, roughly. In all honesty, I'd say don't print faster than 85. Core XY, I'll happily print at 400 millimeters a second. So considerably faster, and I'll end up with a better product and a better finish. And the other, so space, and you want to print of multiple colors. So a lot of things with every printer will be at least a single color. I said, we saw a picture there. Some models have a multi hot end. They'll have 2 filaments coming into there that they'll just move ahead and start using the other colour. Some there have multi-hot end arrangement where they'll actually have different filaments into 4 different hot ends, and they'll actually mount that one there to use it. Or the bamboo with the AMS, automatic material handling system, where it has automatically feeds the materials in and out. So, and that was the only other thing I didn't mention there with those exotics. The feeding of these materials, once again, is mechanical generally through brass gear set. So if you've got problems with your material feeding in and out, if you haven't got hardened steel there and printing exotics, they are going to wear, and it's a source of frustration for anyone that may have worn their first gear set out and wonder why their prints are failing. So, and printing in multiple colours. So there's a object. We've just got a couple of things here. You've got this little container we've got here. Put it in front of the things for a second. People can see. Just sit up there for a sec so you see it on the camera. Just down there. So I didn't manually, I go, well, how does this all work? And that's within the slicer software. I said, oh, at this point, stop using this colour, load this colour and print that colour. So you can do all those sort of things. So it's pretty sort of, so you just sort of see, that's just an object, a nice little container. So you can pass it on around and please. And when it goes around, there's one of the things I used for testing with was my little SMA spanners, because they're great for learning how to. It's a small object, prints in 7 to 8 minutes, mechanically useful, and it's actually a torque wrench because it's printed with you print the layers there. It's not the same as a $50 torque wrench you buy. Much better than fingers, but it's relatively accurate and easy to reproduce your actual tension. It's not perfect, but. And I just chucked 2 of them in with my my V&As and everything. I just have 2 or 3 of them in the box because they're a disposable item. And a great way, it's something that I'm not just printing something to throw it out to calibrate and learn the characteristics of different materials as I was learning. So please take at least 2 each. If you don't show me you've got 2 on the way out, I'm going to make you take 3 on the way out the door. Yeah. And so just a couple of things up there, some of the common issues you might find with printing. We've talked about all of these things as we've gone along. I'm not going to read them out. They're there for you to have a look at. One of the big issues is, of course, bed adhesion. And once you learn the right temperature and the very simple thing that these materials hate the oil off your skin, it's really a matter about getting that temperature right for the material you're printing so you get good adhesion, keeping that build plate clean, couple of ways. Isopropyl alcohol dissolve the oils off your skin when you've touched it, or any of the very high quality dishwashing liquids is probably the absolute best material to use. And if you, as you start going through printing some of the more exotics, there are some very, very expensive adhesives that are super good that you can use, that are sticky when they're hot and let go at about 22, 23 degrees. So they're perfect. So it's really about learning some of these things about your material and learning the capabilities of what you're doing. So we're getting close towards the end. So I did say we weren't going to cover the basics, but where's the fun in that? I am going to go one tiny little step, and it'll become obvious in a minute. I won't start that bit until everyone's seen those 2 little doorknobs we printed that go around the whole room here. Then I'll dive into that. So a lot of the models you can download for free. They've got a little monitor next to them. They're parametric, which means that there's a software I can punch in and change some parameters of them, but while maintaining the others. So anyone that sort of think within your slicer, you can do basic things like scaling the size of the object. But if you need to scale it, that scales the whole object in the X, Y, or the Z. So if it's any sort of design tolerances, you've just blown them unless you're scaling them, keeping them all X, Y, and Z. And you scale something with moderate tolerances to 200%, your tolerances are sloppy and loose. And so it's beyond that. And so I'm just a couple of things we've got. So that box, the tricolored box we passed around, is, once again, it's a very nice parametric model I found. We can do all sorts of things like changing the size of the screws in there, the dimensions in the X, Y, and Z, putting slots in.
There is a translation.
Hello.
It was taken November 19.
Okay. Change the X, Y, and Z. That particular one, we can also do things like add some slots in there, put a circuit board in, put a hole in the end, and there's someone else has actually modelled the cable gland you can print that actually fits to that hole that you can model around it too. So all sorts of stuff, and that's 100% free. I'm not paying for that design work and things go on there. And the other thing is, like, there's lots and lots of things you can change. And a lot of the models out there, people, what I call a remix on them. So they use SCAD software, which I'm going to open up in a couple of minutes. And we're going to play with that exact doorknob we printed out and show you from a basic model. Everyone been right through? Yeah. Of how we can play with that. So just before we jump into that, I'm going to just pause for a minute. We'll take a couple of questions, then I'll jump into looking at that, playing with that SCAD and having a quick look before we wrap it up for the night. Yeah.
Right. Yeah, good evening. The filaments, you say are hygroscopic, so don't get them wet or keep them dry.
Yep.
So then how's it cured? It's the heat in the nozzle.
It's all about temperature. So they're all designed to be like I said, liquid at a temperature. And that's where we looked at the parameters there.
Yes.
The temperature, we'll flick back to that. That's understanding that. Somewhere back about there, is it? That's a good guess. So we look there, as we said, the PLA melts at around about 210 degrees. It'll turn to a solid at normal temperatures. And once it gets back up to 60 degrees C is when it'll start to deform. So it's all about the temperature. So we're melting them at a temperature, depositing them and cooling them down fairly quickly so they maintain their shape and position. Answer the question? Thank you.
Any other questions for the whole?
And I know she married my father later, so she's not just a bigamist, she's a
Background, listen. Got it.
Just further on the temperature question, in terms of, because you're talking there for a bit about enclosures for temperature control in addition to fume removal.
Yep.
The goal there for the ambient temperature for the room that the printer's in is as low as you can keep it below the
deformation
temperature,
or if as we see there, or below the adhesion temperature. So a good question about the temperature. So and enclosures. This is why I said there's 3 easy filaments to print, and I'm covering just the very basics of those exotics. Some of those materials need a very stable temperature, and an enclosure is required. Almost essential for ASA. Temperature variations while you're printing and rapid cooling, it will deform while it's being printed, and the item will actually warp on the print bed, a corner will jump off, or things like that. Some of the materials in my early prints where you think it printed perfectly, you go and have a look at it, then you find that one side is 15 mil high and the other side is the 25 mil high that it was meant to be, because it's just slowly lifted off on a corner while you're doing the print. So that's why I said the easy ones you can print almost anywhere with minimum of fuss. Once you get the more exotics and the harder to print ones, that's why I said this is an introduction. Work out what you're trying to achieve with your printer, what materials I think you might want, because that really does influence what is the best printer for you. And so those ones some of those definitely need an enclosure, or you're going to be in for a world of pain.
Yeah, good evening. Just remind me what you said about the higher you print, what the main problem was. Was it temperature control, or was it the
height?
Like, for example, how did you print those two without too much distortion?
Okay, so with this one, like I said, you mean like a bed slinger, the object is in motion the whole time is moving. If we look at our precision, we're pointing in precision of 0.06 of a millimeter. So that print head in relation to that print bed needs to maintain a resolution of 0.06 of a millimetre, well, 0.06 of a millimetre steps. Anytime there's movement, when something gets taller, it's going to wobble regardless. So the taller you get, it's going to start moving more and more. You're laying a layer down. It's not exactly where you think it is because the object is slightly out of kilter where you are. So a fixed bed, so a core XY, that's what I'm saying, core XY, and that's why it enables you to print faster because the object itself is moving very, very slowly, but only in the Z axis.
How many printers do you have, and when are you buying your next one?
I only have two, but there is another one in the shopping cart that I haven't quite pressed buy on yet.
Any other questions from the hall? Anything from Zoom?
Go to Zoom if there's any there.
Make sure to unmute yourself and then mute after.
I've got a question, if you can hear me.
Go for it.
Yeah, what about power efficiency, or is there much difference between the XY and the bed slinger models as far as power usage?
Excellent question. I didn't know myself, so I bought a bloody power meter and put it on. Even with a heated bed, 85 watts and that, 85 watts. That's it. So
Okay.
about 6 cents or 5 cents or 4 cents an hour. Zero difference whether it's the type of printer it is. So
Thank
the
you.
only difference is you're printing the exotics that require that slightly higher temperature. They do tend to warm the cabinet up. But yeah, the cost is absolutely far less than I thought it was. Certainly sub 100 watts total power.
Great, thank you.
Any
What
more
is
questions from Zoom?
what is the printer that you're about to hit the buy button on?
It might be another bamboo. Yeah.
Bamboo X1 carbon?
No, I've already got a bamboo X1 carbon.
Okay.
So I started at the top and worked my way down. No, because yeah, and that's a good question too. What is my next one going to be? Honestly, it's going to be a smaller form factor printer. I do not need 250 by 250 by 250 for most things I do. I've probably printed less than 10 things where I would have need to exceed the capabilities of the A1 Mini. And of course, I'm going to get an AMS because I've just fallen in love with the material handling and the ability to do multi-color, multi-change. Never care about running out of filaments when you've got 4 kilos sitting there, because I'm not going to put four kilos on there at any given time. So you can just forget about it. And there's some awesome third-party add-ons that someone's made, an automatic plate changer, so you can set up and stack 10 print plates in a row, prints the plate, automatic changes, and goes on to the next one. So, yeah. I mean, not that I want to do that, but I'd like to have the option. So I've got a couple of other little things.
One question from Zoom, Peter VK5FO. I came in a bit late, sorry about that. Metallic prints, did you cover that tonight, please? Go ahead.
No, I didn't, because this is the basics, and that's a far more exotic material.
Yeah.
And I haven't even looked at it myself, so I won't try and cover something I have no idea or experience with. Thank you.
Excellent. Thank you.
There's a couple of little things in the hall to hand around. So please take one. First in, best dress. There's 10 or 12 or 15 AREG keychains. And if you really want a little another key tag with an RF non-ionizing RF tag, please take one. And like I said, first in, best dress. So fight over them if you really want one. So just before I finish up, I said I wasn't going to cover anything beyond the basics, but I do want to have a quick look at what I talked about, just parametric modeling and SCAD. SCAD is really, they're very generous when they do it. And so it's a little software package here. And as we saw, might be a doorknob that we printed a couple of them out of. And this is the basic parametric model. I'll just zoom that as much as I can so you can see it as much as we can. And this is a pretty good example of a parametric model that's given us bucket loads of things we can change on here. It changes some properties, but not all. So with this one, I'm just going to stick my head in here and try and see all the things. The very first thing we can do, we see this one's got a screw hole that goes from the top to right through. So you'd put a screw in the top. If we look down there, it's got various depths, so it changes its diameter. So we can change the diameter of that hole in this object. I'll make it a bigger screw hole, and we will, where's the render button? Let's see that. Preview. Yeah, I'd already changed it. So we could, so this particular one, all we're doing is changing that screw hole size. So that's a pretty, like an interesting, so, well, I've just made a brand new unique object that's perfectly suited to what I wanted. So the story behind this, I wanted a knob. I had a quick look at Bunnings. It's going to cost me $9 for something that would have been okay. Bunnings, a round trip to Bunnings is 35 minutes. So, but in the meantime, I found this parametric design. I downloaded it, opened it in SCAD, modified it to exactly the size I wanted it, and printed it out. And like we said, we saw there, printed 2 out in about 25 minutes. Did the whole thing quicker than I would have. I had it finished before I would have got back from Bunnings, and rather than costing me $9 and probably a lot more because I was walking around Bunnings, it cost me like 60 cents. So pretty cool thing. And another parameter. We're looking at the top of the object. Do I want the screw to come in from the front or the rear? I've got to preview that one. Did I select rear? No, it didn't do it, did it? It's going to make a liar of me, not changing things, but that's all right. No, I didn't change it to rear, that's why. So now I've just changed that parameter. No hole in the top, I'm screwing it in from the bottom. Do all sorts of things with this particular one. Change the diameter of the hole. And you notice some of the object changes around it too, because it's a fixed parameter of how much material there is around the screw. So it's some of those parameters are changing this one. How big of a screw have I got? These particular ones, I designed them around a standard M5 bolt. Do I want to make a bigger hole? Do I want to? No, that's fine. Yeah, screw. Once again, I can change the depth of the screw, how deep the hole is. Lots of things I can change it. So I can change the handle, the height of it, and we just drag that parameter there. You can sort of see what it does. Suddenly I've got a very short shaft, but a very large knob on the top of it. And it scales all aspects of it. Let's zoom out of that a bit. So you can see now, if we look at that, that's going to be like 130 centimeters across, 130 millimeters across the moon, so, which is a bit, do we need a big knob for the SDR? So we just change that so we see it there. Once again, just different parameters we're changing. How big the height of the knob do we want? And there was another stem height was there as well, so change the stem. So just simple things like, and this is as far as I've gone in trying to design anything parametric. Play with the parametric, find something close, get a parametric model, have a play with it. This one's put a base around it. So yeah. Well, the other option, I think there was another option there. I can make that rather than round, I can make it square. And the last one there is this one here. If we look at the top lip there, we can see that in this instance, it's a beveled edge, and the other one here is just like, I'll change that to a radius edge because I wanted a smooth edge on the knob. So just basic things like that. That's as far as I've gone with trying to do anything, because there's crap loads of stuff out there, more and more every day. Lots of it's free. Or sometimes there's a better object, you might pay $5 to $10 for a model, and I don't begrudge someone a few bucks for their time in designing something if it's what I'm after. That's all I want to share tonight. I hope everyone's got a little bit of an insight into, answering that question of whether it's something right for them now, or just enough information to say, well, what do I need to consider so that my first choice isn't a terrible choice. Thank you, everyone.